Hello to all. Welcome to this next section of the training Introduction to Remote Sensing in GIS using QGIS. Today we are going to talk about rainfall data interpolation and visualization using QGIS. My name is Sukan Jain and I'm working as a scientist C in National Institute of Hydrology. So let's begin. So the objective of this particular session is that first of all, we will try to understand that how to import and visualize rainfall data. So there are various methods to load the dataset. Currently, we are going to work on the point dataset, which contains latitude, longitude information of any location. Then we will try to understand the different type of interpolation techniques. In the current session, we are going to conduct two interpolation techniques. One is IDW and another is Thiessen polygon methods. Then using these two interpolation methods, we will try to create a continuous surfaces, also known as raster, from the point data sets. And in the final deliverables of this particular session, we will try to create rainfall maps and apply different kind of symbology and design over our that map. So the question arises why we need to use interpolation techniques. So in the case of rainfall or in the case of many kinds of other data sets, we usually receive discrete data points, like the data points are scattered in a different places. That means that particular data denotes to that particular location or a lat long. So in order to create a continuous map out of that, we will try to use interpolation. So by interpolating discrete data points, we will try to create continuous distribution that need for a continuous rainfall distribution for modeling and planning. In this case, we are going to talk about the rainfall data, but in other case, it can be any kind of data. For example, groundwater data or any type of disease map or maybe population data or any kind of data which denotes to a single location or a single point. And we will it helps the continuous distribution helps us to visualize the data set properly. For example, if you just look into this but small example, that in this case we can see that the points which are located in the upper half of this particular area denotes a higher amount of rainfall, for example this area. So this information cannot be apprehended by a user using just point data set. This information can easily be understood to many users using the continuous surface raster, and that continuous surface raster can be created using interpolation techniques. And using different type of visualization, we can create different type of gradient map. Like in this case we can see that the higher blue color denotes, or it might denote some higher rainfall value, and the lower the brighter portion denotes the lower rainfall value. So these kinds of parameter, this kind of visualization techniques can help your user to understand the dataset properly. And the application in the rainfall data, or currently because we are talking about the rainfall data, it is applicable in hydrological modeling, agriculture planning, weather forecasting, risk assessment. But as I told you that it is not only paid for the rainfall data, but in any kind of data in any field of data. So when we talk about the rainfall data, usually the rainfall data that user received is in the gauge format, like in the gauge data set source from the IMD or from the state agency. And usually the gauge data set are come as in the Excel file or CSV file or a text file, where we got the information of any station name, latitude, longitude, and the values which we want to gather the information. Then other type of data set, the rainfall, other type of format that we receive the rainfall data set is graded rainfall. And sometimes user also try to collect those data sets. For example, if you go to a field and you collect any specific information from the field, so that information denotes for that particular point, not for the whole of the location. So in order to create the raster map of whole of the location, we use the interpolation technique. So in this particular case, we will going to utilize a rainfall data set, which is stored in the CSV format, and which include the station name, latitude, longitude, and rainfall amount. And the advantage of QGIS is that it can directly import such kind of format. So there are various type of interpolation method. The currently the very which are very popular is one of this Thiessen polygon. So Thiessen polygon is a deterministic kind of model. It is a zone based, that means equal influence boundary, and it is used a simple aerial average, that means no mathematical or strong mathematical computation is there. Then very popular another method is used as the IDW, which is also a simplistic kind of method, a deterministic approach, which also create a continuous raster. It is used to create a smooth rainfall gradient. So these two techniques are widely used in the rainfall in the hydrology domain. Other kind of technique is kriging. It is also very popular. It is a geostatistical approach, and it is a model based, and it is a kind of advanced analysis because a strong mathematical computation is going to be happen behind this particular kriging method. So first of all, let's talk about the manual way of creating Thiessen polygon. So first of all, we have a point data set. Okay, so we try to plot these point data sets on a graph paper or on a map. Then we try to connect these points by a line. As you can see that these points are connected by a line. So first of all, we try to plot the points, mark all the data points accurately on a map or a graph paper. Then connect nearby points, draw a straight line between each point to its nearest neighbor. For example, this is the point, and then in the neighboring of this point, all these points are located. So we will create a line by connecting this original point to all of its neighbor. So you can see that this type of triangular network diagram will be prepared when you connect these points. Now, the third step is to find midpoints and mark the midpoint of each connecting line. For example, this is a connecting line, so we have to identify this particular midpoint of each and every line. As you can see, this is the point, this is the point, this is the point, this is the point. Now, in the next step, we need to draw a perpendicular bisector from each point and draw a line at 90-degree to connecting the line. For example, this is the midpoint where my mouse red color is denote. This is the point. We need to connect this point by a line. So, in a triangle, these are the three midsection, and we need to connect. And the darker, that means the dark blue line, is nothing but our Thiessen polygon. So it is a very old and good technique to create a continuous rainfall data set. So initially, without having the GIS software, this was the manual way to creating Thiessen polygon map. But with the help of GIS, this type of map can be created with just a few clicks. Another method that we've also talked about, the IDW, as the name suggests, inverse distance weightage. It estimates the value based on the inverse of the distance from. For example, this is the point of which we have a data set, and we want to estimate the data of this particular point. So it will carry the weightage as a inversely proportional to the distance. For example, if we calculate the distance of this particular area with this point and with this point, we came to know that this point is having a least distance, and this is a heavy, very big distance, and this particular point is very far distance. So it will take the weightage of this point based on the inverse proportional of its distance. Next is the Kriging method. Kriging approach. It is a geostatistical methad that models spatial surface, natural neighbor. It is a kind of Thiessen polygon, but not in the rainfall, but in the other domain. It's based on the Voronoi telestation of the known points. And another is a spline. It uses the pieces-wise polynomials to create a smooth surface. So as I told you that many of the GIS software support many other kinds of interpolation techniques, but in this case, we are going to talk about two simple approach. One is the Voronoi polygon, also known as Thiessen polygon, and another is IDW. Now, the factors which affect the interpolation accuracy is first of all is the density and distribution of the stations. It's a simple thing that if we have a number of if we have more number of points of the rainfall data set or any other data set, the accuracy of our interpolation will be increased. The higher the station density and uniform the spatial distribution, it improves the interpolation accuracy. Its sparse or clustered station can lead to a poor estimate in the data sparse region. For example, if I talk about Himalayan region or any region where the rainfall station is less, so in that cases, your output or the accuracy of interpolation might not be that much adequate. Terrain characteristics also very important, like topography significantly influences the rainfall patterns. Complex terrain with a varying elevation, slope, and aspect requires careful consideration in interpolation method. Like if you talk about maybe hilly area, So in a hilly area, a tendency that it receives a more amount of rainfall, but a plain area which is a very nearby to that hilly area might not receive that much amount of rainfall. So these type of terrain or topographic effects can highlight the accuracy or the adequacy of our interpolation techniques. Temporal variation is also very much important, like event based or mean rainfall patterns. The storm events show high spatial variability, while the long term average are somewhat spatially smooth. Then the choice of method and the parameter. The selection of interpolation method like IDW, kriging, and the parameter tuning. So in this case, we are going to talk about few of the parameters through which we can tune our accuracy. So this is a common workflow of adopting any kind of interpolation technique. First of all, we will try to create our dataset into the CSV format. As I told you that GIS support few of the format that can be directly imported into the QGIS like CSV, tab delimited, etc. For example, if you get any dataset into the Excel format, so we need to convert that Excel format into the CSV or tab delimited. Then it can be imported to the QGIS very easily. Then we can import that data set in the QGIS, then project the data. So usually the data set are not in a project coordinated system or a correct coordinated system. So we need to modify that as per our need. Then we will try to apply the interpolation like IDW, spline, Thiessen, polygon, etc. Then we will try to visualize our map using some different kind of techniques. Then we will try to clip a raster, clip our output of interpolation using our any boundary, and we will create a layout, and the final output will be the complete rainfall map. So to continue this exercise, we will going to open our QGIS. So in this case, we are using QGIS version 3.4.0.7. So the interpolation technique that I have talked about, like IDW tracking, can be found in latest or the QGIS 3 and above version. You can use any of this, but try to utilize the QGIS version which having a term known as long-term release, because it supports some advanced techniques without any bugs or with a few bugs. So this is our QGIS window. First of all, we'll try to understand what kind of data we are going to deal with. So in this session, we have created a dummy data set. First of all, I'll just open this data set. So as the name suggests, it is a Uttarakhand rainfall dataset. In the Excel, we can visualize that it has four columns. One is station, and station is nothing but the district name of Uttarakhand. Another is latitude, then we have longitude, and then we have rainfall mm. So this is the information that we usually get from any rainfall station data set. So we can say that these are the rainfall data set of average annual, that is average annual, long term average annual rainfall of these particular stations. So first of all, we will try to plot this data set. If I close this particular data set and just open this format by right click and click on show more options, properties. So I can see that this particular data is in the CSV format. So CSV format is nothing but the comma separated version. If I open this data set into a normal notepad or notepad plus plus, like if I click edit in notepad, I can see that this data is denotes in the comma separated information, that after each and every entry, the entry is separated by a comma. So this kind of data set is very easy to import into the QGIS. So as I told you, we first of all open the QGIS. Okay, we will create a new project. So it's a good habit to work in a project so that the progress of those project can be saved. So we will go to the project, new project, and first of all we will create open the layer. So we'll go to the layer, add layer. Now you can see that there are several options. Add vector layer. So vector layer usually denotes shapefile, KML, or GeoJSON file. Raster layer is denoted as like GeoTIFF, JPG. Then we have mesh layer, but we are going to use add delimited text layer, because as I told you, our data set in the text format with a comma separated variable. So we will click on add delimited text. This window will be open. As you can say, you can change this type of data set if you want to import using this particular window also. Like this is for vector, raster, mesh, point cloud, delimited text. So first of all, we will click on this file name, three dots, to open our file. I'll just go to my path where my data set is loaded. So you can see that in the filter menu, only these kind of formats are there, like text, CSV, DAT, WKT, TSV. So as I told you that it is very easy to import CSV dataset. I'll just click on my CSV file, click on open. Now it is very important for a user to understand their dataset. So as I told you that first of all we need to provide the format, either it is CSV, regular expression, or custom delimiter. It can be possible that this kind this information is not delimited by a comma, but maybe by a space, or maybe by a some other parameter like hash or any other thing. So that data set can also be easily visualized. So in this case, we will select CSV, that is comma separated version. Then next important thing is the geometry definition. What if we don't have the latitude and longitude information of this dataset? Then we won't be able to plot our dataset in the GIS domain. But we have those geometry information. That's why we've defined the geometry definition. So if you don't have the latitude longitude information, you can say that it is a no geometry. But though we know that we have a geometry information, we click on point coordinates, and here the x field is the longitude and y field is the latitude. So if we go to our header, we know that longitude is stored as longitude, LONGITUD, and latitude is stored at LATIDUDED. So it automatically has taken the correct longitude and latitude. But we can change this by this drop down menu. So all of these four header are available in our CSV dataset. So for the X field, we collect longitude, and for the Y field, we collect latitude. So this latitude and longitude can also be in UTM. That means easting and northing. So that depends upon what kind of data set the user is dealing with. So but our current data set is having the information with the latitude and longitude. We will leave this field as a blank. Now the next thing is that the geometry CRS. That means in which particular geometry this data set is there. So by default it is selected as UTM-44, but we know that this is not a UTM-44 denotation. Our latitude longitude is denoted at 29.62 and 79.67. That means degree decimals. So in order to visualize the degree decimals, we usually select APSG 4326 WGS 84. It is a default coordinate reference system which is generally used for worldwide visualization. If this drop down is not coming into your QGIS, you can go to this button, click on this button, that means select CRS, and in this filter we can search for EPSG or simply code word 4326. So now you can see that if I click on this WGS84, this particular highlight, which is highlighted to 343 north, will be for the whole world. I'll just click on this. Now you can see this particular WGS84 EPSG4326 is denoted for whole of the world. So I click on OK. Now it has been updated. Now we can before importing, we can cross check that our data set is properly visualized. Right, we have a station name, latitude, longitude, and rainfall. And not only that, we got also the information about the data type of that particular column. So these are the station name, that's why it is denoted as a text string. This is denoted in decimal, and this is denoted in integer. It can be integer and it can be decimal as per the data requirement. So after I just click add, and I can see that a data set has been added. I'll just click close. Now I can see that some random points are visualizing in my screen into the QGIS, and my data set is loaded into the layer panel. Okay. Now we are not getting any information that this data set belongs to which area. So for that purpose, either we can use some base map or some other GIS layer. Like currently, I'm going to first of all use a base map of Google Map or any open map. So for that purpose, I am using a toolbar known as HCM GIS. This is a plugin. You can install any type of plugin by going to the plugins, manage and install plugin, and you can search for HCM GIS. Okay, there are other kind of plugins are also there, which can be utilized to get the base map of Google or Open Land Map series, etc. So I'm going to use the open HCMGIS. So after clicking on HCMGIS, you can click on install plugin. But in my computer, in my QGIS, the plugin has already been installed, so I don't need to install it again. I'll just go to the HCMGIS, click on base map, and I'll just click on Google Map. Now I can see that Google Map is there, but my point has been vanished. It is because my point layer is below in the hierarchical, in this hierarchy. So I'll just carry this, click on this Google Map and drag below this Uttarakhand rainfall dataset. Now you can see that over our Google Map, we can clearly visualize our point dataset. Okay, there are, if you don't want to put it on the Google Map, you can always create or take any other kind of GIS file. For example, in this case, we are going to bring in this folder, we have also another shape file which is known as India underscore state updated, which is the updated state boundary of India. So first of all, I will open this particular file. So I'll just go to the layer, add layer. In this case, I know that my state boundaries are in the vector format, that means shape file. So I'll just click on add vector layer, click on this, make sure this is click on file, click on this three dot, and now you can see that there are several India state updated cpg dbf prj. So usually we need to open shp, but if a user is new and don't know which particular format is to be open, so we can filter the shapefile with ESRI shapefile, ESRI shapefile. If I click on this filter, we can see that only the file which is .shp will be displayed. So I'll just click on this and click on open and click on add and close. Now I can see that a layer has been added. Now my point data set is not visualized because in the hierarchy, my point data set is below this particular polygon. So I'll just click on this and snatch it to the above, or I can click on this and use these two buttons. That means, not this two button, but right click on this and click on move to the top and move to the bottom. So I can see that these are the points. So in order to visualize this particular polygon file into the full scale, I'll just right click on this and click on zoom to layer. Now, the things can be visualized in a more informative and prominent manner. We can see that this particular shape file is nothing but a polygon shape file. The polygon denotes the different states of the India, and this is the point data set. If I'll just right click on this, click on zoom to layers. So these points denotes to the Uttarakhand station rainfall data set. So next thing that we will do is, first of all, we will try to visualize this point using this point data set. So I'll just uncheck these two layers and click on this Uttarakhand rainfall data. Right click on this and click on properties. in the properties, I'll just go to the symbology, and I can change the symbology by any particular marker. Like this is a triangular polygon. So, but at the same time, I just want to visualize. So I can do, in order to open this symbology layer, I'll just click on this particular layer and click on this topmost right hand side corner, left hand side button, that is open layer styling panel. I just click on this. So in my right hand side, a layer styling panel will display. Now I just need to change the basic styling of this particular points. So instead of single symbol, I'll just click on graduated, and in the value, I need to select the column. So as you can see that only three columns are denoted, not all the four. If you just click on the so if I open the attribute table of this layer, I can see that there are four columns: station, latitude, longitude, and rainfall. So, but in this particular column, station name is not there because this is in the string format, and all the other three columns are in the integer or the decimal whole number format. So I'll just click on the rainfall, and I'll just click on any of the color ramp. So for example, spectral, and click on, uh, if I just move downwards, click on classify. So I can see that my point data, which was initially visualized by a single color, now visualizing by discrete colors, different colors, where the red value denotes the lower amount of rainfall. That means nearby, you can see in the legend, red denotes the rainfall value from 1020 to 1200, but the dark blue denotes the rainfall from 1800 to 2300. You can change this value by clicking on this particular button and change this. You can change this particular limit, but our prime object is to create a continuous surface raster, and for that purpose I just go to the Thiessen polygon. So before creating Thiessen polygon, we have to make sure that our data set doesn't denote any missing values. For example, if I just open the attribute table, so in this case we do not have any missing values. If there is a missing values, we just need to either delete that thing, or we may have to make sure that that value doesn't denote zero. Otherwise, the spatial average will be become error sum. So what we will do next, the thing that we will select is the Thiessen polygon, and Thiessen polygon for this particular to in order to create a Thiessen polygon, we will go to the vector, and we will go to the geometry tool. In the geometry tool, we can see that there is a function known as Voronoi polygons. Okay, either you can go by this, or you just can, if you forget that in which particular information Voronoi polygon was there, just go to the processing toolbox. I'll just close this symbology layer and search for Voronoi. So if you search for VOR, so we can see that there is a function known as Voronoi polygons. I'll just double click on this, and there are the few options like input layer. We will select the Uttarakhand rainfall dataset. Okay, and there is the option using selected features only. What if I don't want to create the Voronoi polygon for whole of this area? I just select only a few of this area. For example, if I click on this select button and select only this area, so now if I click on this Voronoi polygon, this option become accessible. Because if you don't want to create all of this Voronoi polygon for all of this point, I'll just select this point and check on this button. But in this case, I'm not going to do that. So I'll just uncheck all, and again click on Voronoi polygon, select Uttarakhand rainfall, then buffer region. Currently, we will put it as 0, and I will tell you later that how it is important. And in order to understand this particular algorithm in a full way, you can always click on help. Then a web page in your browser will be open, in which all the details of this particular function will be there like Voronoi polygons. It takes the point layer and generated a polygon layer containing the Voronoi polygons. Now afterwards, if you go downwards to this, you can see that there are multiple inputs, multiple parameters that it require, like input layer, buffer region, tolerance, optional, which is optional, attribute from the input layer, and other things which we will look one by one. So I'll just leave as it is 0, and tolerance will be 0. And I'm not creating a permanent layer, just to create a temporary layer and click on run. So now I can see that a layer has been generated. I'll just close this. And now again, my point has been hide. So I'll just select this. Now this is my one eye polygon, and this is my point data set. Now I'll open my Uttarakhand state boundary. So this Uttarakhand state boundary is not only for Uttarakhand. So I'll just use a filter to visualize only my Uttarakhand state boundary. For that purpose, you'll just right click on this India state updated, go to the properties, go to the action, or in the simple way, just a shortcut is that click on this India state boundary and click on Control F. So query builder will be open, and I want to apply a query that state, I know that the state name is in the state. I'll just double click on this state, will be there, equal to, I'll just click on all, so that all the state name will be displayed over here. So I click on Uttarakhand. So now you can see that my query is state is equal to Uttarakhand. I'll just click OK. Now you can see that all the other state has been gone, only the Uttarakhand state is visible. Make sure that the other states are not deleted. It is only temporarily not visualized. As you can see that there is a filter sign is activated. So if you close this sign, if you close this layer and open it again, all the layer will be visualized as per the original boundary. So now you can see that my Voronoi polygon is not up to the state boundary. Some of the areas are missing. Okay. So now here comes, I'll just open again this line function, click on Uttarakhand file. Now here is the function of buffer region, that means percentage of the extent. If you go to the original plugin website, so you can see that buffer region percentage of extract is nothing but the extent of the output layer will be this much bigger than the extent of the input layer. So my input layer has the extent only up to this area where my arrow is going. Okay, but why I want to extend the extent. So whatever I'll do, I'll just use this function. So first of all, I'll just use this 10% of the original size. I'll just click on run. Now I can see that another layer has been generated, which is slightly bigger than the previous layer, but still my Uttarakhand boundary is not covered. So I'll just from 20, I'll 10, I plus to 25, and let's see. Still, my Uttarakhand is not fully covered. So what we will do, I'll just do it 30. Still it is not there, then maybe 35. I don't know, 45. Okay, so now 45 layer is final. You can see that we have not saved each and every time because we were creating multiple outputs. So what I will do, this is my final output. This brown is my final output. Now I will select all the other output which is not utilized. I'll just right click on this and click on remove. So as this was the temporary layer, so this was not saved permanently, so there is no loss of memory. I'll just close this button, and now I can see that if I'll just open my state boundary. Okay, what I can do in order to visualize all the three layers, I'll just use this symbology, right click on this, go to the properties, or click on this, go to the layer styling panel, and make my state boundary as a transparent. Right, and I'll just drag this above. Now I can see that my state boundary is denoted as red color, and Voronoi polygon is a brown color, and these are the points. Now I can clearly visualize that yes, Voronoi polygon has been created with this particular area. N- Now we will try to clip our Voronoi polygon by using this state boundary. So what will I do? Before that, we have to make sure that the projection system of both of the layer should be same. And after that, I'll just go to the processing toolbox and search for clip. And in the clip, we have to provide input layer as my Thiessen polygon layer. That means, oh, sorry, I think, okay, this clip is for point cloud data management. I need to use clip of vector overlay. So I'll just click on clip. In the input layer, I'll just need to select Voronoi polygons, that is my Thiessen polygon, and overlay layer is state boundary of Uttarakhand. So currently it is named as India state boundary, and I will not save this dataset permanently, and just click run. Now I just close this and let's see. I'll just uncheck all of this other things, and this is my clip Voronoi polygon. This is my state boundary, red color. So now I can see that I got the Voronoi polygon only of Uttarakhand state. Now next we will try to create a continuous raster. So for that purpose we are going to, or before that, what we can do, we can visualize this vector set also. I'll just click on this clipped boundary and click on this layer styling panel and change the symbology from single symbol to graduated, like we did with the point data set. And the value we will create is the take is the rainfall and the color ramp we'll just take spectral and click on classify. Now you can see that we can simply see that the point which denotes with the lower rainfall value red color initially, the polygon associated, the Thiessen polygon associated with that point also come in that color. So this thing can be converted into the raster set also. So what you need to do, just go to the processing toolbox and click on vector to raster. Search for vector to raster. So now you can see that there is an option known as polygonize. That means raster to vector, but we need. So what we can do, vector to raster. This is the function, or you can just simply go to the raster conversion vector to raster. That means rasterize. So in the input layer, we will click on use clipped boundary. That means our Thiessen polygon clip layer, and the field for using which field we want to create a raster. So we will take rainfall and fixed value to burn. It is we will put it as 0, and the resolution. This is also very important thing, that at which spatial resolution we want to create the raster. As we know that our point data set are not dense, it is a very scatter. So we can initially use like zero point zero 0.01. So here zero point zero 0.01 means when you use 1, it is approximately 100 kilometer, or exactly 111 kilometer. For the sake of thumb calculation, we will consider as 100 kilometer. Zero point 0.1 is 10 kilometer, and zero point zero 0.01 is 1 kilometer, and 0.001 is 100 meter. So vertical resolution should also be the same, and I will leave as it is, output extent as it is, not changing anything, and click on run. Okay, output raster size it is asking. Okay, size unit pixels, and click on run. It is not created successfully. I'll just go to the parameter and click on georeference unit and click on run. Okay, now it is been created. Now you can see that a continuous raster has been created. But of course, the sudden change will be there because it is a Thiessen polygon approach, and this map can be utilized in your reports format, and you can change the symbology of this particular raster also. For that purpose, again, you just click on this rasterize, click on this scale lining panel, styling panel, and from single band gray we will just select single band pseudo color, and single band pseudo color we can change this color ramp like spectral. We can change this discrete or exact or linear. You can experiment with other things. And okay, so this is the final map. We can change the layer. As you all know that currently we are working in the temporary raster. So what you can do, I'll just right click on this, click on export and make this raster a permanent raster. Click on save as, select the format as geotiff. So QGIS support all of this raster format, but we are going to use the geotiff. Click on this three dot so that I can provide the whole file name. So this was my working directory. I'll just paste my working directory over here. I'll just copy. So I'll just copy my working directory and paste it over here. Click on interpolation, and this interpolation is Voronoi polygon, or I can say Thiessen polygon, and click on save. Everything remain as it is and click OK. And I'll just remove all the other layers. Okay. Now, as I've told you that we are going to perform this similar exercise with another method known as IDW, that means inverse distance weightage method. So for that purpose, I'll just click on this uh, processing, go to the toolbox and search for IDW, or I can simply go to the raster analysis, or no, sorry, interpolation. So these are the four formats. So for creating the raster from the points, we will use IDW. Okay, in the IDW, first of all, it is asking for the input parameters. I'll just click on this input parameters at Uttarakhand rainfall dataset, and the attribute or the column which we want to interpolate is rainfall and click on plus sign. Okay, this is the point dataset, and this is another important factor is the distance coefficient p. In order to understand what is distance coefficient p, I'll just click on help so that the detailed information about this tool will be displayed. So this is the information about IDW interpolation. With this interpolation and distance coefficient is nothing but it set the distance coefficient for the maximum interpolation. For example, if we select 100, so apart from this particular distance, the interpolation weightage will not be take place. So by default, we will take as a 2. Extend is nothing but the same as initially we were providing the buffer of analysis, but here we are not providing the buffer, we are providing the extend to which it going to be copy the area. So I'll just click on this and click calculate from layer, because we will want to provide the extent of Uttarakhand boundary with our output, and Uttarakhand boundary is stored in this particular India underscore state updated. As you can see that it has automatically taken the latitude longitude of Uttarakhand boundary, and this is the raster size. We can reduce or increase this size. So currently it is zero point 0.1. Zero point 0.1, as I told you, it is 10 kilometer approximately, but we want to take 100 meters. So you, as you can see that the number of rows and columns, that means the number of pixels will be increased. And this is the interpolated. So currently we want to save this as a temporary file and click on run. It will take time, as because we have decreased the spatial resolution, or we can say increase the number of pixels we want to get as an output. So if I just close this, I can see that I'll just uncheck my Bornoi polygon. Now we have got the raster, which provides the similar information but in a different format. Initially, one eye polygon has a discrete kind of polygon, but interpolated. That means this is the IDW provides a continuous surface. But now also this is not as per our boundary, but as a per our Uttarakhand boundary extent. So what we'll do now, we will try to use the clip function for the raster. So I as just type clip. We need to search for raster clip, or you can go to the raster extraction, clip raster by mask layer. So I just select this clip raster by mask layer. In the input layer, I'll just select interpolated. In the mask layer, I'll just select India state updated, which denotes the Uttarakhand boundary. Then I will leave source CRS and target CRF as blank. Then target extent is also blank. And I'll just click run and let's see our result. So yes, our clip dataset has been created, but still, okay, yes. I'll just close first of all this, and I can see that another layer has been created, that is clip, which is clipped to our state boundary. Now this information looks more informative. So we can change the symbology of this raster also. So I just click on this clip mask, go to the, also before that I'll just export this as a permanent layer. We just select the format as geotiff and click on the file name, three dot, and this time we will provide the uh, as IDW geotiff. Save, everything remain will be as it is. I'll just remove the unwanted layer. So this is my IDW layer. I'll just go to the layer styling panel and click on this single band pseudo color. We can change, or we want to remain as it is. We can do that. Apply. Okay, this is also continuous. We can change this quantity, but we want to remain as continuous. You can change these values also. Now this is our IDW raster, and this is our one eye polygon. I will also change the symbology as the, so you can select the black white or black and white, because this only provide the discrete color, or we can just simply select in any of this and click on this I button to check the value. Okay, as you can see, this value 1660, 1400, 200, 2318, and we want to see the values of both of this thing. So I'll just select both of this and click use this I button and click on this, and I'll just first of all uncheck this. Now I can see that, okay. So in this particular, you can see that there is an option known as view as table. Okay. Now you can visualize both of this point side by side, like over this point, over this pixel, the IDW value is 1611, but the one my polygon is 1620. If I just select this particular point, here the IDW here the IDW denotes 1674, but the Voronoi polygon is 2318, which is a very vast difference. I'll just click over this. This also very vast distance. So if I just visualize my point, or if I want to display the values of this point, what can I do? I'll just go to the scale line styling panel and click on this labeling and single label will click on rainfall mm. Now I can visualize the value of this original point, and then I'll just select these two layers and click on anywhere else. So here I can see that this particular point where I click is close to 3 points. One is this much, this which is denotes at 2318. Another is 2020, and another is 1020. So this, as per the IDW, this is the average of all of these three, where the weightage of the farthest most point is less and the closest most point is high. But in the Voronoi polygon, it this particular point takes the value of this particular area. This particular area didn't gets the value of this particular points. So this is the what we can say, a simple technique of Voronoi polygon. Is a very simplistic approach, but widely used because it is very easy to plot the manual, and when we have a very least number of station points. But IDW, as it is a GIS technique, it is a much more advanced technique to get the informative right manner. If you go to the processing tool in the toolbox, you can get other type of interpolation technique, as I told you in the slide, like kriging. So for the kriging, you need to have a Saga plugin installed. In order to do that, you just go to the plugin, manage plugins, and search for Saga. So now the Saga plugin come with a Saga next gen provider. You just need to install this. After installing this, you will get kriging also. And like there are four type of kriging: ordinary, regression, simple, and you can go for this spline also. If you go for this spline, so there are B splines, thin spline plate, tin. So there are any number of method also, and not only that, there are some of the dedicated plugins are also there that provides the interpolation. So if you go to the plugin, search for interpolation. So you can find that raster value aggregator. So this is also plugin which is smooth and interpolate grid from a raster layer using a regular grid interpolator from SciPy, is a Python language. Okay, and I think this is also a interpolation, but specifically create for some other purposes. This is specifically created from the GNS purpose. I don't know about this network. So as I told you that interpolation is not only for the hydrology; it can be used for other purpose also. And if a user want to create their own interpolation or any kind of plugin, they can create on their own. Let's just see if there any plugin for kriging. I don't know. There's agri calculator. Okay, okay, it is for some urban planners. Okay, smart map. Okay, smart map is interpolation using ordinary kriging and machine learning support vector machine. So if sometime this dedicated plugins or integrated functions not work, you can always use this particular dedicated plugins used for that purpose. So that's it for the day. Hope you like the session, and if you got any doubt, first of all you need to try these exercises on your own. Then if you got any doubt, you can always ask. Thank you.